And here we go, back at it again with some geometry. My favorite tree. We are doing chapter 4-4, S and SAS, which stands for side, 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 and side, angle, side. All right, here we go. Postulate 4.1 says side, 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 congruence. So if three sides of one triangle are congruent to three sides of a second triangle, then those triangles are congruent. Pretty simple. So, if we want to write a proof, here we go. We know that GH is congruent to KJ, and we know that HL is congruent to JL, and L is the midpoint of GK. We're to prove that these two triangles are congruent. So here we go. We are given GH and KG. We are given HL and JL. And we know that L is the midpoint. So if L is the midpoint, we can state that GL is congruent to KL. That's the midpoint theorem. And so, if all three sides are congruent to each other, these two triangles are congruent due to the side, side, side postulate. An included angle. An included angle is the angle between two adjacent sides. So an angle formed by two adjacent sides of a polygon, like the angle at K here between JKL, or here PKR. Okay, postulate 4.2 is side angle side congruent, or SAS congruence. Okay, that says if two sides and the angle between them. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then those triangles are congruent. So if I want to write a proof for this, here we go. What are we given? We know that BC and DC are congruent. We know that FC and EC are congruent, and we also know these two angles, the included angle here, are congruent. Now we are to prove that this angle CFD, so this angle right here, is congruent to CEB. All right, so we're going to prove that. We'll make a two-column proof. First, list everything we're given, our congruent statements, and then we know that these two triangles, BCF and DCE, are congruent due to side angle side. So we know this triangle is congruent to this triangle. What that means is that this angle right here, CED, is going to be congruent to CFB. Okay, those two are congruent, and that is due to CPCTC. That's congruent parts of congruent triangles are congruent. CPCTC. Okay, if you didn't know what this means, write that down. Congruent parts of congruent triangles are congruent. And then I know that this angle that we're looking for here adds to 180. It's supplementary, or it's a linear pair to angle CFB. Okay, together they add to 180. And same thing on the other side. And since these two are congruent, we know that these two are going to be congruent. If we substitute, and there we go. Ta-da! Side, 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 side angle side. That's all there is to it. Like and subscribe.